I'm going to walk you through a short version of the project that we've got the kids doing. These kids are starting with a map that's basically just a weird convoluted shape. And this is a very simple shape, but it's much the same thing. I've sent the kids home and had them turn their map into triangles. And you'll notice this is not a triangle, so we're going to take this simplified map and turn it into triangles. The reasoning behind turning everything into a triangle is that we know the formula for the area of a triangle. Happens to be area of a triangle is equal to base times height divided by 2. So we very simply just turn whatever territory we have into, as accurately as we can, into triangles. Now I have an example of one of the actual maps here that we can see, and you'll notice it's a lot more complex, but you can still turn these pieces into triangles. I have the kids using a ruler. I'm just kind of giving you an idea of what it is we're doing. The other thing that these kids have is a key. All right, you'll notice on this key 1,000 feet is equal to is equal to 7.4 centimeters. All right, and the kids should be able to figure out using a calculator that that means for every centimeter, if you take 1,000 divide it by 7.4, you have 135.14 feet for every 1 centimeter. All right, this is what we're going to use to determine how large this area right here really is. So I'm going to use this same measurement, this same 135.14 feet per centimeter. We'll write it like this. Feet per centimeter. I'm going to use that same measurement value as we work on this little simplified map right here. Okay? So here we go. I've got this simplified map. I know that 1 centimeter is equal to 135.14 feet, and I need to find the area of this in inches squared. Now this area is much larger because of this conversion right here. So here's what I do. I look at the first triangle, triangle 1, and I ask myself, what's the best side of this triangle to measure? Where would the base be best? Right here, right here, right here? Which one? I always use the longest side as the base because it's a lot easier for me to find my my height. All right, so I'm going to use this long side as the base for triangle number 1. I measure that base, and I find it to be 13.2 centimeters. And so I say the base in centimeters is 13.2. Now I'm going to look for the height. The height of this triangle, which some people confuse, is not the length of one of the other sides. The height of the triangle is the shortest distance from the base to the top, which basically sits right about there. So this red marker represents the height from the tip of the triangle down to its base. If I measure that height, I get 4.8 centimeters. This is in centimeters. I get 4.8. Now we know that base times height divided by 2 is the formula that we're going to use to find the area of that triangle. But we want the base in the right unit. What unit are we using? We're using inches squared. And we're talking about real inches, and this is a map of a huge area where 135 feet is just 1 centimeter on here. So this is 135 feet, this is 270, and so on and so forth. So what we really need to do is take these two measurements, and we need to convert those two measurements into feet and then inches. How do I convert these to feet? Well, I need to take the base in centimeters and multiply that by 135.14 feet per centimeter. $13.2 times 135.14. So in reality, if I was to go outside and walk along this line from this point to this point, that base would be 1,783.85 feet long. And if I were to walk from this point up to this point along the height of that triangle, it would be 648.67267 feet long. So this now is our new base and our new height in feet. Do I still have it in inches yet? See, I'm still looking for inches squared, so I actually have to convert these ones to inches. So this is in centimeters. Multiply by feet per centimeter to get this answer. And now I need to multiply by what to get inches? I have linear feet, which means for each linear feet I have 12 inches. So I have to multiply each of these by 12 to get how many inches long each of these lines is in real life. Right? Now that we've got everything set in inches, okay, we can use our formula for the area of a triangle. Do we do that? The base times the height divided by 2. We have our base. We're going to multiply that by our height. Then we're going to divide that whole thing by 2. Is a huge number, but if we count back, 1, 2, 3, 1, 2, 3, 166,624,304. We still have to divide that by 2. And now we have to look at our units. Our units say inches times inches, and so we know this is in inches squared. And that's how we know we're getting the area correct, that it's an area, because we've just squared our units. Now let's take this number and divide it by 2. 83,312,152 inches squared. And that is the area in square inches of that first triangle. And make sure you check your own computations with kind of what we have there. You'll be all right. Now I'm going to do the other triangle. I'm going to speed it up a little bit so you can just kind of see how it works again. There. Now, I've determined the area of the first triangle and the area of the second triangle. So to get the area of the map, I simply add that area to that area. And I get this big fat number right here. $239,525,005 inches squared. So there's some piece of property out there, or some piece of land out there that's shaped something like this, and I have the capacity, using a key like this one and some ratios like this, to determine how big that property is, or this property, in real time, in its real form, out there in the desert. Okay, in whatever unit that I want. In this case, we're using inches squared.